ICSE ಕ್ಲಾಸ್ 10 ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ. Yes, good evening, my dear students. Welcome to our second session. And you must have, all of you new, any of your friends are joining, let them go to the Lokji channel. In the description box only, we have kept the WhatsApp group link. Directly ask them to open the Lokji channel, go to the description box and click their link. Directly that will you can your friends can join. Okay, we have made the ICSE. There are 3 groups are there. Particularly ICSE group, WhatsApp group is there. Click on that, join the group, inform your friends, relatives anywhere in Karnataka. Okay, ICSE students. So let us start working today. Every alternative day you will have one day chemistry, one day maths, Monday chemistry, Tuesday maths, Wednesday chemistry, Thursday maths. Today is Thursday, therefore we will start mathematics. Friday chemistry and Saturday maths. Sunday test. From next week the test will begin. I will go on giving you details one by one. And what I observed in the syllabus of the ICSE is that I will start with the tough to easy. The tough chapters in the syllabus are, first one is the trigonometry and heights and distances. And second is mensuration. Application based problems will come there. And third I will give you that other chapters, algebra chapters. Okay. And therefore I thought many students are feeling difficult in trigonometry and applications, and the second chapter is mensuration. Then we will come to other chapters, algebra chapters. Okay, let us start learning trigonometry this week. What is trigonometry? This is the new branch you are introduced with. One is the trigonometry, another one is coordinate geometry, and both these branches originate from the geometry only. They are derived from the developed, improvised from the geometry only, and particularly trigonometry is a application tool. It is for the first time used by Egyptians to measure heights and distances. One of the application of the trigonometry is to measure the height. Suppose that you are standing before the Qutub Minar. The height of the Qutub Minar can be measured without actually climbing it with a thread. You can sit on the ground and using trigonometric concepts, you can measure the height of it. And suppose that you are sitting on a lighthouse, and you can measure the distance between the 2 ships, and distance between the 2 places, and the height of the pyramid or Taj Mahal or Gol Gumbaz, anything height can be measured. Height of a tree can be measured very easily. Later in application part, you will be learning it. Therefore, trigonometry is one of the application tool, and it will be developed in 11th standard and 12th standard next year. You will be, another branch will be introduced. Now you are already being introduced into arithmetic, algebra, right, geometry, then coordinate geometry, and now trigonometry. In the 11th standard, another branch comes, that is called as calculus, developed by Sir Isaac Newton, Leibniz. Both of them together developed the calculus branch. To learn calculus, you need the trigonometry chapter, very, very important. Therefore, you make your trigonometry very, very strong. Therefore, I particularly selected this chapter, and I will select tough chapters, generally where students are finding difficulty in the first level, and in the second level I will come to easier chapters. We'll go from tough to easy, not easy to tough. Easy chapters anybody can learn it, but tough chapters to score high marks. Tough chapters you focus first, and next you can focus on the easy chapters. Okay, let us start with the trigonometry. This particular word trigonometry has got three words, as you know. One is a tri. Tri means what? Three. Gono. Gono means angle. Angle. Metria. You can open your notebook and classwork book, my dear students. I have put the instruction in the WhatsApp group. Generally, don't chat in your personal number, chat in the WhatsApp group only. If you have got any doubts, any things, after watching the video, you can ask questions. I will put assignment there, practice questions, and even question papers of Icse and written tests. And Sunday on the app, you will have the MCQ test. That will be a time-based quiz. Immediately will get the answer. Step by step, I will come. I will start the test from next week. App-based test on Sunday, and written test also will be sent to you at a particular time after covering the chapter. Subjective tests and objective tests separately taken. Okay, therefore have a separate classwork book, open a pen and paper, have the atmosphere of the classroom. Okay, and you note down, jot down the important points I am talking here. See, this particular meaning of it is a trigonometria. Metria means measurement. Wherever you come across metria, like trigonometry, stoichiometry, coordinate geometry, wherever you get metria, means a measurement. Meaning is measurement. Means trigonometry meaning is what? Tree means a triangle. Tree means a triangle, right? Measurement of the angles of the triangle. It was started earlier to measure the angles of a triangle. And second point in it is relation between sides and angles. Now you take a triangle. Initially, the trigonometry was applied to the right angle triangle. In later stages, it can be applied to all type of the triangles, acute angles, obtuse angle, all other triangles. You can apply trigonometry. But initial, it was applied to the right angle triangle. Observe, in a right angle triangle you studied, there will be one angle will be 90 degree. You can observe here. I have drawn a right angle triangle ABC, and this angle B is 90 degree. The side opposite to the right angle we call in a trigonometry, or it is called as hypotenuse side. We will write it as capital H. This symbol we will use H. Okay. And adjacent side and opposite side depend on with respect to which angle you are finding the relation between the angle and the sides. Therefore, trigonometry can be defined. Let us try to define the trigonometry. Trigonometry can be defined as, you can note down the definition of the trigonometry. Definition of trigonometry. It is the branch of mathematics. You can suppose that 1 mark question is asked. The branch of mathematics which deals with mathematics, which deals with the study of measurement of angles. Keyword it is measurement of angles, and relation between, very important thing, and relation between sides and angles of the triangle. Relation between sides and angles of the triangle. Angles of the triangle. Relation between sides and angles of the triangle means trigonometry is a extension of the triangle. geometry part is called as trigonometry. Is called trigonometry. Trigonometry. Definition. Always write the definition in inverted comma, right? The branch of mathematics which deals with the study of the keywords are measurement of angles and the relation between sides and angles of the triangle. These are the two keywords. Observe, let us try to understand it in the right angle triangle. Suppose that you are measuring the relation between angle C and the sides of the triangle. How many sides are there in a right angle triangle or any triangle? If you take any triangle you can draw. In a trigonometry, there is a convention. You take any triangle, say A, B, C. Observe, in any triangle, how many parameters are there in any triangle? A triangle is a plane figure bounded by three sides. It is a closed plane figure bounded by three sides. The parameters are angle A, angle B, angle C. In a trigonometry, by convention, we take the side opposite to angle A as a small a, side opposite to angle B as a small letter B, side opposite to angle C is taken as small letter C. Even in Heron's formula also, we are using the same convention. Remember this convention in any triangle. In the study of trigonometry, we will be using this convention. Okay, and generally, hypotenuse side is the longest side in a right angle triangle. This point you remember and you can note it. In a right angle triangle, which is the longest side? Longest side is hypotenuse side and its length will be fixed. But adjacent side and opposite side will interchange depending upon with respect to which angle you are studying. For example, you are studying the trigonometry relation between this angle C and the sides, right? In that case, this angle C, the side opposite to this angle C is, which side it is? AB is the opposite side. Therefore, with respect to angle C, opposite side is AB. And this particular base, generally we call in a triangle this one as a base. This base is called as adjacent side. What it is called as? Adjacent side. It is called as adjacent side. Adjacent side. It is adjacent side. Adjacent side. First thing you have to learn how the sides are named in trigonometry. Adjacent side. Okay, this is opposite and it is adjacent side. Suppose that you are measuring. I will draw another same right angle triangle so that you will not get confused. I will draw the same right angle triangle ABC here. Observe. Observe. And this is A, this is B, this is C. We will use the short form. Adjacent we call it as capital A and opposite we will call it as capital O, so that the smaller the letters, lesser the words and faster will be the memory. This one is a hypotenuse. Suppose that you are measuring this time the ratio with respect to A, then these opposite and adjacent sides will interchange. This is the key concept you have to remember in the trigonometry first. Many students do confusions here. They will get confused. This A, the side opposite to A now becomes what? Opposite side. Opposite to the angle A, angle with respect to which you are measuring. And automatically this becomes what? Adjacent. I hope you got the point here. Means angle B will not at all participate in trigonometric ratios 90 degree. Only these two acute angles, angle A and angle C. With respect to angle C, what is opposite? AB is opposite, BC is adjacent. With respect to angle A, what is opposite? BC is opposite and AB is adjacent. This is the first point. You clearly note down in your notebook how the side changes. Okay. Remember, H for hypotenuse, A for adjacent, O for opposite. We will make use of these short symbols so that we can quickly learn. Okay. I hope you noted this definition. I will rub this and move on to the second important point. Now, given three sides, right? How many ratios taken two at a time? How many ratios you can make? Let us take the first right angle triangle. Okay, not this one. Okay, with respect to this, we'll study. What do you mean by ratio? We are going to define what is a trigonometry T ratio. In short, henceforth, we'll write a trigonometric ratios as T ratios, capital T ratios. What do you mean by ratio? Ratio means what? A fraction. Fraction will have what? Numerator and denominator. Clear it here. And this particular ratio, right? With respect to this angle C, let us not take this A. With respect to this angle C, how many ratios we can make? Out of three, taken three sides at a time, by permutation you can say that. How many ratios of taken two at a time? How many ratios can be formed? Just let us see. AB upon AC, one ratio. It's reciprocal. AC upon AB is second ratio. Third ratio will be BC upon AC or AC upon BC. It's reciprocal. And AB upon BC and BC upon AB. Or using our symbol, that is, you can take O upon H or H upon O, short form. And A upon H, A stands for adjacent side, A upon H, H upon A. And O upon A and A upon O. Like this, how many ratios are possible? Totally 6 ratios are possible. I will take our symbol. O upon H is one ratio. And H upon O is another ratio. Clear? I will write it here and is equal to, I will write and leave it. What is O upon H? We will try to clear it. This particular ratio, opposite upon hypotenuse in the trigonometry, is called as a one trigonometric ratio. This ratio we write it as sine ratio, SINE, sine ratio of angle C. Sine ratio of angle C, opposite upon hypotenuse. And this we have to write the symbol symbolically for our calculations. We are writing it as symbol small s. Remember, IN, first letter should not be capital, and leave the space, write the capital C. Therefore, we call it as sine C is equal to opposite upon hypotenuse. This is the first ratio. Therefore, we can write it as sine of any angle, say here C is equal to opposite upon hypotenuse. This is the first trigonometric ratio. I will put a box here and give it ratio number 1. Okay. Similarly, I will take the second ratio. It's reciprocal. Opposite upon, what do you mean by reciprocal? If you interchange numerator and denominator, you will get reciprocal, right? This is hypotenuse upon opposite. Hypotenuse upon opposite. Hypotenuse upon opposite is in trigonometry we call it as cosecant ratio of angle C. Symbolically, we write it as cosec C. You are not writing completely cosecant. The symbolic representation in trigonometry is small letter co, sec, leave space, C. Cosec C is a reciprocal of it, and thus we got the second ratio. What is the second ratio? Cosec C is equal to hypotenuse upon opposite. You remember this ratio. To make it very easy, I have given a symbol there. You remember sine as a SOH. SOH means sine is opposite upon hypotenuse. Any angle. Sine of any angle will be opposite upon hypotenuse. And remember this, need not remember the cosec, because cosec is just reciprocal of it. If a sine C comes out to be 1 by 2, say sine C is a 2 by 3, automatically cosec C will be what? 3 by 2. Like this. And need not remember, only remember sine ratio. You can easily reproduce a cosec by taking the reciprocal of it. Right? There are 3 ratios are there, 3 reciprocal ratios are there, totally 6. Very, very easy to remember. Okay? Nice. Let us move on to the next ratios. I will take the second ratio. Which one? I will take adjacent upon hypotenuse. I will take adjacent. What is the symbol we have given for adjacent? A upon H. And take the reciprocal of it. H upon A. Second possibility. This is the second ratio. Second ratio. We are going for the third and fourth. Remaining 2 will be 5 and 6. Only 6 trigonometric ratios are there. Make them perfect first. Then we will develop the trigonometry. And this particular adjacent upon hypotenuse in the language of trigonometry, we call it as cosine ratio. What it is called as? C-O-S-I-N-E, cosine ratio of angle C. And mathematically, and we write the symbol as cos C, C-O-S capital C, cos C. Henceforth, you can remember that cos C is equal to what? Adjacent upon hypotenuse, and thus you got the third trigonometric ratio. And remember it by using the trick SOH. Similarly, you can remember this one as CAH. Easy to remember. Cos is adjacent upon hypotenuse. Easy to remember. Use this trick. And its reciprocal you need not remember. Just interchange numerator and denominator, and that is called as cosecant ratio. What it is called as? Secant ratio. S-E-C-A-N-T. Secant ratio of angle C. Symbolically, we write it as sec C. C is SEC C. Don't read. Many students read it as sin. No, not like that. It is actually SINE, sine. And cosecant, short form is cosec. Right? And this one is cosine. Okay? You read it as cosine C only, cos C. Even if you write cos C, pronounce it as cos C, no problem. Don't write first letter capital. These are the rules. Don't write first letter capital. Second ratio is written as SECC. Okay? Thus we got the fourth one. Fourth one is sec C is equal to hypotenuse upon adjacent. Put a box and remember the fourth trigonometric ratio. Right? Given 3 sides, randomly you can choose any 2 ratios and you will get one trigonometric ratio. If you take opposite upon hypotenuse, you will get a sine ratio. Hypotenuse upon opposite, you will get a cosecant ratio, cosec ratio. And adjacent upon hypotenuse, if you take a cosine ratio, hypotenuse upon adjacent, if you take a secant ratio. Now you are left with only 2, opposite and adjacent. And if I take the ratio, third ratio here, that is opposite upon hypotenuse. If I take a trigonometry. Let me write here, take the ratio. If I take the ratio of opposite upon hypotenuse, in the language of trigonometry, we call it as tangent ratio. Tangent ratio of angle, angle C. And this short form of this one is written as small letter tan, T-A-N, leave the space C, tan C. Now you got the fifth one. You can write it in a box, that is tan C is equal to, what is the definition? Opposite upon adjacent. Put a box, give the number. Fifth, there are only 6 trigonometric ratios, like there are only 7 notes in a music. Similarly, these are the notes in the trigonometry. 6 trigonometric ratios are the ನೀವು ಹೆಂಗ ಸಂಗೀತದೊಳಗೆ 7 ಸ್ವರಗಳು ಇರ್ತಾವಲ್ಲ ಆ ತರ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿ ಒಳಗೆ ಏನವ 6 ಸ್ವರಗಳವ. These are the basic things. First step in learning trigonometry is making these perfect. How to, what is the trick to remember? Like remembered tan is a T, right? Opposite upon adjacent, TOA, right? I have written here, you can see. SOH means what? Sine is opposite upon hypotenuse. Cos is CH, cos is adjacent upon hypotenuse. Tan is opposite upon adjacent. And cosec can be, what is cosec? Cosec will be hypotenuse upon opposite. Cosec will be, right? Cosec will be, its reciprocal will be, cosec will be what? Hypotenuse upon opposite. Similarly, what is the reciprocal of cos? Reciprocal of cos is sec. Second will be hypotenuse upon adjacent. Similarly, reciprocal of tan. If I take reciprocal of tan, last one I will write here, that is a hypotenuse upon opposite. So what will be hypotenuse upon opposite? We'll try to understand. Hypotenuse upon opposite. Okay, hypotenuse upon opposite is called as reciprocal of tan. We call it as cotangent. It's called as cotangent ratio of angle C. In short, the symbol uses small letter c, OT, cot C. Thus you got the sixth ratio. How you write it as? You write it as cot C is equal to hypotenuse upon opposite upon adjacent, tangent. We are left with only opposite upon adjacent. Opposite upon adjacent is called as tangent ratio, and adjacent upon opposite is called as cotangent ratio. That is this is opposite. Opposite upon adjacent is called as tan. Its reciprocal is called as cot. You can even remember like this also. What is sine? Sine is opposite upon hypotenuse, and that is cosec is hypotenuse upon adjacent, and cos is adjacent upon hypotenuse, and sec is hypotenuse upon adjacent. Tan is opposite upon adjacent, and cot is adjacent upon opposite. That is adjacent upon opposite, right? Therefore, symbol is TOA. TOA means tan ratio is opposite upon adjacent. Then cot ratio will be what? Cot ratio will be adjacent upon opposite. You need not remember this. Only remember these three. These three can be easily reproduced. SOH means sine is opposite upon hypotenuse. Cos is adjacent upon hypotenuse. Tan is opposite upon adjacent. These are the 6 trigonometric ratios. This is the first step in learning the trigonometry. 6 trigonometric ratios. I will keep only that much. Then we will move on to the next thing now. Okay. I will draw right angle triangle. Now we will see what are the possible values of a sine and cos. Say, if I take a right angle triangle, let me rub this. I hope you have noted all of them. Note down. Have pen and paper. Don't watch like a movie. And it is consider it as a classroom. Now see here. I told you that in any right angle triangle, if you observe carefully, let me take a right angle triangle. That is A, B, C. This one is hypotenuse. Let us assume that this one is angle theta. Generally, in trigonometry, we are using trigonometric ratios, theta, Greek letters, and this one is say adjacent, and with respect to theta, this one is opposite. Observe here. The trigonometric ratio sin theta I will write. Now, can you tell me what is sin theta? Sin theta is equal to opposite upon hypotenuse. And what is cosec theta? I will write cosec theta. Apply now. Practice. What is cosec theta? Cosec theta is a hypotenuse upon opposite. And can you take a cos theta? What is cos theta? Cos theta is equal to adjacent upon, yes, hypotenuse. And sec theta, the reciprocal is reciprocal of cos is, that is their formula, that is reciprocal hypotenuse upon adjacent. And next one is tan theta. Tan theta is opposite upon adjacent. Its reciprocal will be cot theta. Cot theta will be adjacent upon opposite. 6 ratios already. Now my third point, after learning trigonometric ratio, the third point I want to bring your notice is what type of ratio sin theta will be? Will it be, what type of fraction it will be? Opposite upon hypotenuse. You know that this particular hypotenuse is the longest side, right? Longest side. Therefore, denominator will be bigger or numerator will be bigger? Denominator will be bigger. Then sin theta will be proper or improper fraction? Sin theta will be opposite upon hypotenuse, right? Say if you have 2 by 3, observe, denominator will be bigger, numerator will be smaller. And this particular ratio is a proper fraction or improper fraction? Yes, it is proper. Remember this point, very, very important, because the values of sine. And what about cos theta? If you take cos theta, it is adjacent upon hypotenuse. Again, hypotenuse will be the longest side. Then denominator will be bigger. Therefore, it is also what? A proper fraction. It is also proper fraction. What about tan theta? Opposite upon adjacent. Either opposite may be bigger, adjacent may be bigger. It may be proper or improper. Proper or improper. Both of them are possible in case of tan theta. Are you getting me? Similarly, if you come to cosec theta, observe. Now tell me, cosec theta, will it be hypotenuse upon opposite? Will it be proper or improper? It will be definitely improper because numerator is bigger. What do you mean by improper fraction? What about 2 by 3? 2 by 3 is a proper fraction. What about 3 by 2? Improper. Why it is improper? Numerator is bigger, denominator is smaller. Why it is proper? Numerator is smaller, denominator is bigger. Remember these concepts very clearly. That is improper. Improper. And what about sec theta? Hypotenuse upon adjacent, it will be what? Improper. Again, if you come to cot theta, adjacent upon opposite may be proper or improper. See, opposite may be longer or adjacent may be longer. Adjacent may be smaller, opposite may be bigger. Therefore, it may be proper or improper. This point you carefully note down. And my question is, next question is, what is the highest value of a proper fraction? What is the lowest value of a proper fraction? If I take a proper fraction, 1 by 2, 1 by 4, 1 by 8. If I go on taking, what is 1 by 2 value? Is 0.5. What is 1 by 4 value? 1 by 4 value will be 0.25. 1 by 8 value will be 0. If you take 8 ones are 8, 8 to the 16, 0.15. Goes on decreasing or not? What is the highest value of a proper fraction? Highest value of the proper fraction, if you take the number line, suppose that this is number line, this is 0, right? Suppose this is 1, this is a -1. Highest value of the proper fraction never exceeds 1. If it exceeds 1, observe here. What is the value of 2 by 3? We will calculate. 2 by 3, 0.36 18, 6 0.7. What is 3 by 2? 3 by 2 will be always 2 1s are 2, 2 5s are 10. Observe. Its value is, you take any proper fraction, its value will be less than 1. Remember it carefully. And any improper fraction will have the value greater than 1. Therefore, as sine and cos are, sometimes it may be positive or negative. Okay, values may be positive or negative. Therefore, sine theta, that is sine and cos ratios, value lie between what? -1 and +1. This we write mathematically as -1 is less than or equal to sine theta. Sine theta is less than or equal to 1. Means sine theta never exceeds 1 and never takes the value less than 1. This is the number line. So on up to minus infinity. This is number line 2, 3, so on up to what? Plus infinity. Infinite means undefined. Therefore, sine theta highest value, anybody asks you, tell highest value of sine theta will be 1, lowest value of the sine will be what? -1. Similarly, what about cos theta? Cos theta is also in the same situation. That is, cos theta, lowest value will be 0 and highest value will be 1. It can also have the values -1 to +1, cos theta. Highest value is 1, lowest value is 0. Therefore, it lies between -1 and +1, both sine and cos. But what about cosec? Cosec is improper fraction. Any improper fraction will be always greater than what? 1. Therefore, you can expect that particular cosec and sec. Cosec and sec. Here also sec and cosec will have the values greater than 1. Means from -infinity to -1, from 1 to infinity. Remember, that is a cosec and sec can have, cosec theta and sec theta can have values from -infinity to -1, and they cannot come inside 1 because already sine and cos are here. Sine and cos, only sine and cos will be between -1 and +1. Sec and cosec will be greater than 1 or less than -1. -infinity to -1 or +1 to +infinity. In this range, you can expect the values. What about tan and cot? See, tan and cot may be proper or improper. Means they will cover entire number line. Therefore, tan and cot can have values from -infinity is less than or equal to, or less than not equal to, there is no number. Tan theta is less than +infinity. Similarly, cot theta can also have the values from -infinity to +infinity. This is the third important point I wanted to discuss with you, my dear students. You will be asked simple basic questions on this concept. Many students do not have clear idea about this. Remember on the number line, right? Sin theta and cos theta can have the values between -1 and +1, and sec theta and cosec theta will have the values -infinity to up to -1. They cannot enter inside 1. Between -1 to +1, sec and cosec never enter, and inside -1 and +1, sec and cosec never enter. But tan and cot can cover even because it may be proper or improper, means even -1 +1 also it will cover. Therefore, the tan theta and cot theta value can lie between -infinity to +infinity. Right? This was my first introduction class, my dear students. Whatever points I have shown you, they are very, very important while answering the MCQs. Step by step, concept by concept, I will go on clearly explaining you. Note down them, cleanly mark them, right, and remember them. But when you come across the questions, you will understand. Okay. So in our next mathematics period, day after tomorrow, means today is Thursday. On Saturday, we'll continue with the next concepts in the trigonometry. Tomorrow is chemistry day. Okay, alternative days. Okay, tomorrow is Friday. We'll start chemistry, and I will put what I am discussing every day in the WhatsApp group. What is today's work? Slowly I will start giving you small assignments, questions. You have to solve them, and I will discuss them. Okay, in the WhatsApp group you can tell me the question number, which question you found difficult. Therefore, not only join the Lokji channel, but your friends are joining Lokji channel, they have to immediately join the WhatsApp group, because I'm sending questions, any chatting, because at the live time I cannot see your chats. Therefore, after finishing the live session, I will go through and I will support you throughout here, my dear students. You can inform all your relatives, friends throughout Karnataka, wherever ICSE students are there, to support you at your home. I am a home teacher. I am supporting you on a study table. I know your difficulty is better than you. Therefore, in my experience of more than almost third decade now, I will try to help you. Soon I will meet tomorrow at sharp at 9:15. Okay, some 5-10 minutes time, because I want to reset for your batch. It will take some 5 minutes. By 9:20 I will join. Up to 10 or 10:05 I will finish. Okay. Good night, my dear students. Tomorrow we will meet with the chemistry. Okay, which chapter I am going to talk to you, I will inform you in the WhatsApp group, and pre-read the topic, and whatever you studied in the 9th standard, particularly I am taking the language of chemistry. The language of chemistry was there, no, first chapter. That language of chemistry, how to write radicals, how to write formula, about that I will be talking. Till then, bye bye. See you tomorrow at the same time. Good night, my dear students. ಯಾವಾಗ ಸ್ಫೂರ್ತಿ